Peace be with you, math analysis, or for this semester, trig analysis honor students. May God guide us, enlighten us, and strengthen us, and give us great wisdom as we do this preparation for your upcoming test tomorrow. Number 13, let's take a look at it. Number 13, it says complete the following. So what does it say? The log of a number to a specified base is the exponent. Here's the key, the exponent, and you already know that. Maybe not in these words. It's the exponent to which the, let me just stop right here. The exponent, right here. That's right. It's the exponent to which the base must be raised to get the number. I'll try to remember to rehearse this with you, but the log of a number is the exponent. The key is the exponent, and you know that. The exponent to which the base must be raised to get the number. All right? Let's go ahead and take a look at the other page. Here we've got some evaluations to do, and we touched on some of these. Evaluate the specified logarithmic function without the use of a calculator. This one we did, and this is going to give you some practice on the definition I just gave you. Oops. This is just asking you what's the log of 49 to the base 7. Log of 49 to the base 7. We're looking for the exponent to which 7 must be raised to get 49, and I trust by now you know that's 2. This is log of 1,000. In case you don't know, when you see log by itself like this is called a common log, and the base is understood to be 10. If there's just log, it is understood to be 10. So, what exponent should we raise 10 to get 1,000? The answer is 3. And we did these together. In case you're not sure of this one, ln means log to the base e. So this is what is being asked here. Log of e squared to the base e is what? Or to what exponent should I raise e to get e squared? This one is very close to you. It's the exponent is 2. And finally, ln of 1 means log to the base e of 1. To what exponent should I raise e, which is about 2.718 to get 1? That's going to be 0. All right, we get to these, and this is just, you just do this on your calculator, and these are all exponents. So let's see if I can maybe supply you a couple of answers here. Exponentials. This would be 3 to the 2.5. 3 squared is 9. Okay, and if we're going higher, 3 cubed, which is bigger than 2.5, is 27. So we know this answer is going to be between 9 and 27. Looking for a calculator right now. Let me see if I can find one. But I trust you'll be able to work this out. Maybe I'll check these with you when I see you. This one here is log, and this also I will check. I did this pretty quickly before you left, but let me just indicate what this would be like. Since the base is not 10 or e, you'd have to use your change of base on this one. So you'd have to say log of the number which is raised, which would be 67, over log 4. And by log here I mean log to the base 10. If you do this, log of 67 divided by log of 4, you should get your answer here. Okay, and you should have an idea of what this is, because here's the question: 4 to the what exponent is 67? Well, 4 times 4 is times 4. It would be 16. 16 times 4 is 64. So it's a little bit more than 4 cubed. So your answer here has got to be 3 point something. 3 point something. You can check yourself on that. And then you can work this one out. And just to give you an idea of what you should have, if you have 3 to what exponent will give you close to 30? You probably know that 3 cubed gets you pretty close. It's 27. So the exponent to which you have to raise the base is 3. So it's going to be 3 point something, a little bit more than 3. So that will give you an idea of whether or not you're in the right neighborhood in terms of your answer. All right? Now, how about properties of logarithms to condense the given expressions? Properties of logarithms, here we've got 2 log x plus 3 log y for this one. So let's go ahead and use what is called the power property. So we bring the 2 and make it exponential here. So this becomes log x squared. We do the same thing with the 3. Make it exponential, so this becomes log y cubed. So essentially we just have a log of something plus a log of something, and that will bring into focus what is called the product property. So this now would be log, we use the product, x squared times, or just log x squared y cubed, which means log x squared y cubed. How about this one? This one will be similar because we've got a coefficient before the log, so we bring it forward. So this becomes log z to the 4th minus log w to the 5th. And now we use the quotient property, which looks like this: log z to the 4th over w to the 5th. Okay, that's condensing, bringing it into one logarithm from it being 2. I'm just going to do this one, C, and then you will practice D by yourself. So here we got a subtraction, then an addition here. How do you do that? Well, here we go. We go log. And for the subtraction, it's going to be a quotient. So for the log m minus log n, it would be that. And then we have plus log p. And we could use the product property and bring these together. So here we have log m times p over n. So when you have a plus, it's product. When you have a subtraction, it's division or quotient. So that one is for you, especially you, Leah, if you're watching. And now we're going to go the other way. It says use properties of logarithms to expand the given expressions. So here we have x squared y to the 1/2. So we take this and we make it log. And here we have a product because we have x squared times y times z to the 1/2. So it's going to be x squared. The product becomes plus log of y plus log z to the 1/2, or the square root of z. So this becomes, when we apply or employ the product property, the plus here would make this product, and this plus also would make this product. So here we go, 1 logarithm now. And we use the product x squared y z to the 4th. Z to the 1/2, sorry. Alright, that would be it. And then this one, it's a little bit different, but you just use your product property and your quotient property. So for the r s squared, that becomes log of r plus log of s squared, and then for the division by t, that becomes minus log of t. So this becomes a really expanded log of r plus, I'm going to use the power property and bring the 2 forward, 2 log s, and then minus log t. Alright? Finally here we have converting pi over 3 radians to degrees. So how do you do that again? Well, when we're going from radians to degrees, no calculator here, our conversion factor is 180 over pi. This is degrees, so when we're going to degrees, the degrees are on top with the conversion factor. It's going to be fairly easy for you, because now we can cancel this out. Pi goes into pi once, pi goes into pi once. And we have 180 divided by 3. 3 goes into 18 6 times, and 3 goes into 0, 0. That's 60 degrees. So pi over 3 is 60 degrees. And if we had, let me just make another one up. Let's say we have pi over 2. We want to convert that to degrees. We multiply by the conversion factor of 180 over pi. Divide that out. And then 2 goes into 2 once, 2 goes into 18 9, 2 goes into 0, 0. So that's going to be equal to 90 degrees. No surprise here, because you know that pi over 2 is equal to 90 degrees. Finally, we're going to convert 225 degrees to radians. So it's going to be 225. 225. I'm going to multiply by a conversion factor of not 180 over pi now, but the reciprocal of that. And we're going to radians. The pi is upstairs. So pi over 180. Alright? So this ends in 5, this ends in 0. So 5 can go into both of them. And you can work it out. But 5 can go into 22. 5 times 4 is 20. And 2 left over. 5 will go into 25. 5 times 5 is 25. 5 will go into 18. 5 times 3 is 15. And 3 left over. 5 into 30 is 6. When you look at these numbers, 45 and 36, you know that something will go into both. And I think it's going to be, let's see, I'm thinking 3. 3 will go into this one, 15, and 3 will go into this